All right, guys. So what we're looking at today is another way to solve quadratic equations. We're going to have at least 5 different ways that we're going to solve them. And the way that we're going to go over today, there's 2 of them. One of them is going to be by graphing, and the other is going to be by the square root method. Now, when we graph it, what we're trying to find is we're trying to find the value of x that would make the function 0. Well, when solving any of them, we're trying to find what value of x is going to make the function equal 0. Now, at this point here, we've solved something like this here. We factored it. We did our 2 sets of parentheses, set it equal to 0. Then set each one of those equal to 0 to find out what value of x makes it 0. Now, for graphing, we're really looking at the x-axis, the x-intercepts. Because where this function crosses the x-axis is the value of x that will make the function equal 0. Because at any x-intercept, we have x comma 0, where the value of y is 0. So when we solve these here, we're trying to find out what value of x will make the function equal 0, or the x-intercept. So when we look at this here, if I want to do it by graphing, and really before the graphing calculators, we would have to set up a t-table. I'd have to pick 5 values, one of them being the x-intercept, not the x-intercept, the vertex, and go from there, because it mirrors, it makes a U shape. But one of the things we can do is we can use the graphing calculator to graph this here. Because the graphing calculator will graph any and all functions. So what I want you to do is we're going to open up the graphing calculator. We're going to take our graphing calculator. I'm going to clear that. Hit y equals, because y equals is where we can normally type a function in. So we'll hit y equals, and then we'll type the function in. So you have it on your note sheet. I wrote it up here on the whiteboard. We have x squared minus x minus 6. And once you finish getting that typed in, hit graph. And once you finish doing that, hit graph. Any questions? And here's our variable, this button here. X squared minus x equals 0. Okay, you all got something like this here, yes? Yep. So we want x minus x minus 6. So we just want x squared minus x minus 6. We don't worry about the equal 0. We just want the function. Because what we're trying to find is when the thing equals 0, where it crosses the x-axis. And how many times does this cross the x-axis? Twice, doesn't it? We have 1 over here, and we have 1 here. So we have this point and this point. Now, what are the x values at those 2 points? It's kind of a little hard to see. So what we can do is if you do second graph, you'll get a table. If you do second graph, you'll pull up a table. And again, when we're graphing these, we're trying to find out what value of x will make the value of y equal 0. Or what value of x will make the thing equal 0, this quadratic. Now, the one up here, I see 2. All right, so we have 2 values. One of them is when x is negative 2, and the other is when x is 3. Because these 2 values here, when we plug those in, the y value is 0. So we're looking at a table, we're trying to see what values of x give me a y value of 0. So we have 2 of them. One of them is when x is equal to 3, and the other is when x is equal to negative 2. So our solutions for this are negative 2 and 3. That's it. That's all we have to do for this here. So the solutions for this here by graphing are x is equal to 3 and x is equal to -2. So our solutions and that's all we have to do for this here. That's all we have to do to find the solutions. Any questions on this here? And that's the graph. Let's look at the next one. Let's look at this one here. Now this one here, we have -2x squared minus 2x equals 4x. So again, we're trying to find the value of x that will make this 0, or if we're graphing it, we're trying to find the x-intercepts. Is this thing equal to 0? No, it's equal to 4x. I don't have 0 on either side, so what I'm going to do is we're going to rewrite it. I'm going to make it equal 0. How can I make this equal 0? What can I do? Because I need to move the 4x. Moving the 4x is going to be the easiest way. Yes, we can do it in one step. So what can we do with both sides? I can subtract 4x from both sides, because 4x minus 4x will become what? 0, yes? And that's what we want. Now on the other side, we'll rewrite. We'll have 2x squared minus 4x minus 2. Now because 4x, -4x, or minusing 4x, there's no like terms on that right side, or the left side, sorry. On the left-hand side, -2x squared and -2. These two here are not like terms to our 4x. We don't combine any, because there's no like terms to combine. So we just have this here. So we have it equal to 0, yes? Now with most, there's only like 1 or 2 exceptions to this rule. But most every single time when we have a higher degree polynomial, we have an x squared or multiple terms with x squared, x cubed, like this here, we want to get everything on the same side. We want it to equal 0. And we did that. Now for graphing, well, let's get the graphing calculator out again. So in y equals, we're going to type this thing in. So in the graphing calculator, you'll pull it up. Hit y equals to start with. Let me get mine out. Start off by hitting y equals. Now I would replace the one that's already there. So -2 x squared minus 4x minus 2. And once you finish getting that typed in, hit graph. Once you finish getting that typed in, hit graph. Yes, everybody got the graph? Everybody able to pull this graph up? Yes. It looks something like this here. Yes? So where does it cross the x-axis? So actually, I'd say it touches at -1, yes? It doesn't quite cross it. It meets it there and then kind of goes back down. And if I look at the table, we can see here it does get 0. It does equal 0 at -1. But at the 2 points above, 1 point above and 1 point below, it goes back down, doesn't it? It doesn't actually cross. And that's fine. Because where this equals 0 is that x is equal to -1. Now, technically, it's actually x is equal to -1 and x is equal to -1. It has a multiplicity of 2. We're not too concerned about that here. But any time, especially, well, for these quadratics, whenever the graph comes up and touches the x-axis but doesn't cross it, it's going to have a multiplicity of 2. There's going to be 2 zeros there. We'll get more into this, especially in the next chapter. But every single quadratic that we cover will have 2 answers. They may not be unique answers, but they will have 2. Because for this here, there are two answers. It's -1 and -1. But it's not unique because they have the same value. Does that make sense? So for the homework, if one of these comes up, it's just going to be -1. Because it's just going to have you select which are the correct answers. It's not going to actually have you fill anything in. But that's it for this one here. Questions on this here? We good with this here? For the most part, because it's really what we graph the function and then see where it crosses the x-axis, yes? I'm skipping one. I'm skipping the next one, that x squared minus 8x plus 16. I want to look at this one here. 1/2 x squared equals 6x squared minus 20. Now, as we notice on the last one, hopefully notice that having a negative number in front of x squared, did that really change anything? Did that make it harder or easier? Well, not really. We're just plugging it in. So to make things easier on us, because again, we have to get everything on the same side, I'm just going to subtract the 1/2 x squared, since the sign in front of the x squared doesn't matter for these here. And it doesn't really matter that it's a fraction because it's the calculator doing the work. What we can do is we can subtract 1/2 x squared from both sides. These two here will cancel, becoming 0. And then you have -1/2 x squared plus 6x minus 20. And we just put it in front because it has the highest exponent and there are no like terms. Now we're going to type this into the calculator. And again, as just a reminder, if we want to type in a fraction, we would do alpha y equals enter. Alpha y equals enter will give us a fraction. And once you get it typed in again, just like the last one, hit graph. Once you get it typed in, hit graph. Let's see here. Yep. Yep. Able to get it typed in, looks good. Anybody having issues getting it typed in? We good? Alpha y equals enter. You don't have to hold. So alpha y equals enter. Yeah, so you don't have to hold any of the keys for this. It's just typing them in. So hit graph and see what happens. So where does this cross the x-axis? It doesn't cross. So since it doesn't cross, do we have any x-intercepts? No. So what does that mean the answer for this here is? Well, no, what? No what? No real solutions. So what that means is there is a solution, it's just not real. It's just not a real solution. So we can have a solution. It's like what? An imaginary kind of solution, but we will have a solution. We will have a solution, and it'll make more sense After Friday, tomorrow and Friday, we'll delve into imaginary things. But there is a solution to it. We just don't know how to get it yet. So for now, if it doesn't cross the x-axis, it is no real solution. It's not that it's no solution. There's no real solution for it. We'll find it eventually. Any questions on this here? Any questions on graphing? We like graphing? Yes? All right, let's look at this one here. Now, I have a feeling at this point, y'all feel pretty comfortable with graphing it, yes? So, I have the graph of this already drawn up. So y'all can look at this here. Now, it works out that it touches the x-axis and goes back up at this value here, where x is equal to 1.5. On the tables or the graphs that you have, was 1.5 a value on those tables? No, it went by ones, yes? This is where graphing kind of has its drawback, because we would have to do a lot of special features or functions in it to get this value, which isn't bad. But if we have irrational numbers, non-repeating, non-terminating zeros, or we have these ugly decimals, graphing, especially with this calculator, will not be helpful. It won't be as useful. So graphing works, but not all the time. Because as the one we just saw a minute ago with the non-real solutions, no real solutions, graphing doesn't work. So graphing doesn't work all the time. It works some of the time, it doesn't work all the time. So that's kind of the drawback with graphing. Also, factoring does not work all the time. It only works some of the time. So we've gone over factoring, which works sometimes, graphing, which works sometimes, and what we're about to do is the square root method. Which really just works sometimes. Now, what we do with the square root method, for the most part, sometimes can be worked with graphing, because if it has whole number solutions, it will work. Now, the thing with the square root method is we can't have a middle term. And what I consider by middle term is our ax squared plus bx plus c equals 0. We don't have any terms in our equation that have x to the first by themselves. So looking at this here, we have an x squared term, but we don't have any terms with just x. We don't have an x that's not having a square somewhere attached to it, correct? So this is where we use the square root method. And the first step in the square root method is to get the term that's squared by itself. So let's do that. Let's get the term that's squared by itself. So looking at this here, 4x squared minus 31 equals 49. So what is with our term that's squared, or with x squared? Well, we have two things. We have the 4 and the negative 31, yes? So really what I want to do for this one here is I want to get x squared by itself. So to get x squared by itself, I need to add 31 to both sides, because these two here will cancel. So for the square root method, for this one here, we're trying to get x squared by itself. So the first thing I'm going to do is I'm going to add 31 to both sides. Because when I add 31 to both sides, I will get 4x squared. When I add it to the other side, I will get 80. So we're closer to getting x squared by itself, yes? So what do we need to do next to get x squared by itself? We can divide by 4. And when we do this, well, 4 divided by 4 simplifies, and we just have x squared equals x squared equals 20. Square root both sides and solve. So once we get the variable or the term that's squared by itself, we're going to square root both sides. Because what's the square root of x squared? Well, the square root and square would simplify out, yes? That's what we're doing. That's the process of the square root method. Is because we got x squared by itself, I can square root both sides. And the square root of x squared would just be x, because the square and square root cancel out, yes? That's pretty much what they told you in Algebra 1. When we square root something that's squared, it simplifies, yes? And that's about it. Later in the year, I will go through and explain exactly how this works. Now we have to take the square root of 20. The graphing calculator is not going to be friendly with this here. It's going to give you a decimal. It's going to approximate. So on the test, I would use the yellow calculators, the TI-30XS. Those will simplify in radical form. Because if you plug it into the TI-30XS, it'll give you 2 square root of 5. Wolfram alpha, so if you're doing these at home, would give you this here. And Wolfram alpha, you're probably going to have to do 20 caret 0.5. You all know how to do the caret key, shift 6. It'll do exponents. Or I don't think most of the calculators on the computer will do it, but Wolfram should simplify this here for you. Or the yellow calculators will do it for you. I would try and see if it'll take the square root of 20 as the answer. And if it does, if Big Ideas Math does take it, that's awesome. If not, we'll have to simplify. But we also have to include the plus and minus. Because this number is going into x squared, yes? Well, a positive times a positive is a positive. A negative times a negative is a positive, yes? So whenever we take the square root of both sides, we have to include the plus or minus. We have to include the plus or minus.
How will we put that in?
Just 2 answers. Because really what this is saying is that x is 2 square root of 5, and x is also negative 2 square root of 5. It's saying it's both of these. It's saying it's both of these answers. And I think for most of this chapter here for Big Ideas Math, it's going to have you pick the answers. It'll have a list of numbers there for you to pick, and it'll have these listed out. I don't think it's going to have too many where you actually have to write it out. The test you will. So luckily on the test, you will have those yellow calculators that'll simplify the square root of 20 for you to this here. And you can leave the plus or minus, because on the test, I will take x equals plus or minus 2 square root of 5. Questions on this here? We good with this here so far? Yes? So let's look at this one here. We have 3x squared minus 9 equals 0. So if this does have real answers or whole number answers, graphing would solve it. If it doesn't, we'll have to do a different method than graphing. But we can use the square root method because we do not have a middle term. We don't have a term with x. We just have 3x squared minus 9, yes? So if I use the square root method, I need to get the x squared by itself. And to do that, I'm going to add 9 to both sides. Because when I add 9 to both sides, those will cancel, leaving me with 3x squared on the left-hand side is equal to 9. Now what do we need to do next? We can divide both sides by 3. Which tells us that x squared is equal to 3. Any questions on how we got to this here? So what do we need to do next? We need to Square root both sides. Well, the square root of x squared gives me, well, then we just have the square root of 3. Because if you remember back to when we simplified radicals, or when you simplified radicals in Algebra 1, you were really looking for multiples or factors of that number that were perfect squares. So seeing if 4 was a factor of the number, or 9, or 16, or 25, so that we could simplify them down. But this here doesn't, so it's just x is equal to plus or minus the square root of 3. And because it doesn't reduce, it means the square root of 3 is an irrational number, a non-repeating, non-terminating decimal. That would not be fun to try to find on a graph, would it? No, the answer is no. Because it doesn't hit a nice spot. It is not a fraction. There's no way to write it. It would just be approximately. Any questions on this here? We feel okay with this? Yes, these aren't bad. I will tell you this right now. This one we can still use the square root method for it. Because we don't technically have a middle term. We have x plus 3 as being what? Squared, yes? So if I could get it by itself, well, the square root of x plus 3 squared, well, the square root and the square would cancel out, yes? We can still use this method. We can still use this method to solve. We just need to get the term that is squared. That's why I wrote the term that is squared instead of just a variable squared, but that term, x plus 3 squared, by itself. So what can I do to both sides to get it by itself? Well, I would divide by 2/5. Now, if you're wondering, could we have multiplied both sides by 5/2, the reciprocal? Well, yes. I mean, we're just trying to get rid of that fraction. So dividing both sides by 2/5, or multiplying both sides by 5/2 would do the same thing. I think for some it's easier just to think about dividing by 2/5. Because anything divided by itself is 1, yes? Now on this side over here, we can do 5 divided by 2/5. The calculator will figure that out. It'll do that pretty easily. The graphing calculator, we would do alpha y equals, enter for our fraction. Do 5 in the top, go down to the numerator or denominator, alpha y equals enter. 2/5, and hit enter. And I believe it gives you 25/2, yes? Do we have the term that's squared by itself? Yes, right? So I can square root both sides because the square root and square cancel, yes? So I'm left with x plus 3 equals, so I have to have plus or minus. Now this thing here is 5 square root of 2/2. Now to get this here, the graphing calculator, again, is going to give you a decimal approximation. That's just what it's going to do. Now, to do it in the yellow calculator, I've got to do the square root of 25 over the square root of 2 and hit enter. I have to do them separately. Because the square root of 25 is 5, yes? But it doesn't like having square roots in the denominator, and we have to do something called rationalizing the denominator. I'm not going into specifics about what that is quite yet. You've done a little bit in Algebra 1, but we're going to cover this again when we start talking about rational or roots. These radical functions, we'll go back into it. So I'm not too concerned about it here. But what it ends up being is that when we rationalize it, we'll get 5 square root of 2/2. That's just how it works out. We'll go into more detail with it later. Is x by itself? No. Because we have what? X plus 3, yes? So the last thing I have to do is I have to subtract 3 from both sides to get x by itself. Now, the numbers that we end up adding or subtracting or multiplying and dividing at the end are going to go in front of the plus or minus. They're going to go in front of the plus or minus. Because really what we have here is two separate statements. Because it's saying, really, before we did that was x plus 3 is equal to 5 square root of 2 over 2. And x plus 3 is equal to negative 5 square root of 2 over 2. So then when we subtracted 3, it looks a little bit different. This here, the plus or minus, is an easy way to write this as one statement. It's an easy way to solve this as one statement. Now, one thing I will say, especially going forward and especially on the test, is that this here is the answer. Because this here, as we said, because the square root of 2 is not a whole number, we can't find a whole number for it, right? It's a non-repeating, non-terminating decimal. It's irrational. Is there any way that we could really just add or subtract 3 from it and get something that looks nice, a whole number or a fraction? Well, no, right? So that's the answer. That's it. You're done. Now, if we come down to something and we get x is equal to 3 plus or minus 4, can we do 3 plus 4 and 3 minus 4? Yeah, we can do that. We can get numbers from that. Because I can do 3 plus 4, and I can do x equals 3 minus 4. These here, you have to solve all the way down. If we can get a nice number, a number that does not have a non-terminating, non-repeating decimal, we're solving it all the way to the end. If it has radicals or I that doesn't really simplify or reduce, we leave it in that plus or minus form. But if we can simplify it, we're going to. Questions? Are we good with this here? Yes? There are other ones that we can do, and the process is still the same. And we're not going to worry. I'm going to let you give these here a try. There's 2 on the homework assignment. I'm not going to tell you which, because I want to see how you do on them. They're not going to be counted against you because the answers are a little and one of them's a little tricky, okay? But I want to see how you do on them. Now, come test time, as you've seen, there's different ways. There's going to be at least 5, bless you, that we're going to do. Some of the ones on the test are going to have this kind of phrasing. Solve the equation using the square root method. So those there will be points for using the square root method to solve it. But would you lose all the points if you found the answers doing a different method? No. You would only lose the points that would be associated with using the square root method, yes? So this here is a big kind of message to y'all. If you get stuck on the test and can't remember how to use the square root method but can find other solutions, other ways to find it, find the answers. There's at least find the answers, even if it's not by doing it the correct method. Because there will be a few with each of the methods. I don't remember about square roots. Then there's going to be one that's going to say, solve this by any method. When this shows up, it's not restricting on what you can do. So you can use factoring, you can use graphing, you can use the square root method, or the other 2 we haven't covered. The other 2 that we're going to have 2 more ways to solve it, which will work every single time, no matter what the numbers are. You could use any of those methods. You just need to pick one that you want to do, and you solve it. And that's it. So there's going to be some that you can solve by any method. There's going to be some that restrict you on how you solve it. But that's going to be it.